DreamGaussian, Generative Gaussian Splatting for efficient 3D content creation. Recent advances in 3D content creation mostly leverage optimization-based 3D generation via score distillation sampling, SDS. Though promising results have been exhibited, these methods often suffer from slow per-sample optimization, limiting their practical usage. In this paper, we propose DreamGaussian, a novel 3D content generation framework that achieves both efficiency and quality simultaneously. Our key insight is to design a generative 3D Gaussian splatting model with companioned mesh extraction and texture refinement in UV space. In contrast to the occupancy pruning used in neural radiance fields, we demonstrate that the progressive densification of 3D Gaussians converges significantly faster for 3D generative tasks. To further enhance the texture quality and facilitate downstream applications, we introduce an efficient algorithm to convert 3D Gaussians into textured meshes and apply a fine-tuning stage to refine the details. Extensive experiments demonstrate the superior efficiency and competitive generation quality of our proposed approach. Notably, DreamGaussian produces high-quality textured meshes in just 2 minutes from a single-view image, achieving approximately 10 times acceleration compared to existing methods. Vision transformers need registers. Transformers have recently emerged as a powerful tool for learning visual representations. In this paper, we identify and characterize artifacts in feature maps of both supervised and self-supervised VIT networks. The artifacts correspond to high-norm tokens appearing during inference primarily in low-informative background areas of images that are repurposed for internal computations. We propose a simple yet effective solution based on providing additional tokens to the input sequence of the vision transformer to fill that role. We show that this solution fixes that problem entirely for both supervised and self-supervised models, sets a new state-of-the-art for self-supervised visual models on dense visual prediction tasks, enables object discovery methods with larger models, and most importantly, leads to smoother feature maps and attention maps for downstream visual processing. Text to 3D using Gaussian splatting. In this paper, we present Gaussian splatting-based text-to-3D generation, GSGen, a novel approach for generating high-quality 3D objects. Previous methods suffer from inaccurate geometry and limited fidelity due to the absence of 3D prior and proper representation. We leverage 3D Gaussian splatting, a recent state-of-the-art representation, to address existing shortcomings by exploiting the explicit nature that enables the incorporation of 3D prior. Specifically, our method adopts a progressive optimization strategy, which includes a geometry optimization stage and an appearance refinement stage. In geometry optimization, a coarse representation is established under a 3D geometry prior, along with the ordinary 2D SDS loss, ensuring a sensible and 3D consistent rough shape. Subsequently, the obtained Gaussians undergo an iterative refinement to enrich details. In this stage, we increase the number of Gaussians by compactness-based densification to enhance continuity and improve fidelity. With these designs, our approach can generate 3D content with delicate details and more accurate geometry. Extensive evaluations demonstrate the effectiveness of our method, especially for capturing high-frequency components. Video results are provided at the project's website. Our code is available at the project's website. AnyMAL, an efficient and scalable any-modality augmented language model. We present Any-Modality Augmented Language Model, AnyMAL, a unified model that reasons over diverse input modality signals, that is text, image, video, audio, IMU motion sensor, and generates textual responses. AnyMAL inherits the powerful text-based reasoning abilities of the state-of-the-art LLMs, including Llama 2, 70B, and converts modality-specific signals to the joint textual space through a pre-trained aligner module. To further strengthen the multimodal LLM's capabilities, we fine-tuned the model with a multimodal instruction set manually collected to cover diverse topics and tasks beyond simple QAs. We conduct comprehensive empirical analysis comprising both human and automatic evaluations and demonstrate state-of-the-art performance on various multimodal tasks. MotionLM, multi-agent motion forecasting as language modeling. Reliable forecasting of the future behavior of road agents is a critical component to safe planning in autonomous vehicles. Here, we represent continuous trajectories as sequences of discrete motion tokens and cast multi-agent motion prediction as a language modeling task over this domain. Our model, MotionLM, provides several advantages. First, it does not require anchors or explicit latent variable optimization to learn multimodal distributions. Instead, we leverage a single standard language modeling objective, maximizing the average log probability over sequence tokens. Second, our approach bypasses post-hoc interaction heuristics, where individual agent trajectory generation is conducted prior to interactive scoring. Instead, MotionLM produces joint distributions over interactive agent futures in a single auto-regressive decoding process. In addition, the model's sequential factorization enables temporally causal conditional rollouts. The proposed approach establishes new state-of-the-art performance for multi-agent motion prediction on the Waymo Open Motion dataset, ranking first on the Interactive Challenge leaderboard. Qwen Technical Report. Large language models, LLMs, have revolutionized the field of artificial intelligence, enabling natural language processing tasks that were previously thought to be exclusive to humans. In this work, we introduce Qwen, the first installment of our large language model series. Qwen is a comprehensive language model series that encompasses distinct models with varying parameter counts. It includes Qwen, the base pre-trained language models, and Qwen Chat, the chat models fine-tuned with human alignment techniques. The base language models consistently demonstrate superior performance across a multitude of downstream tasks, and the chat models, particularly those trained using reinforcement learning from human feedback, RLHF, are highly competitive. The chat models possess advanced tool use and planning capabilities for creating agent applications, showcasing impressive performance even when compared to bigger models on complex tasks like utilizing a code interpreter. Furthermore, we have developed coding-specialized models, CodeQwen and CodeQwen Chat, as well as mathematics-focused models, MathQwen Chat, which are built upon base language models. These models demonstrate significantly improved performance in comparison with open-source models and slightly fall behind the proprietary models. AutoCLIP, auto-tuning zero-shot classifiers for vision language models. Classifiers built upon vision language models such as CLIP have shown remarkable zero-shot performance across a broad range of image classification tasks. Prior work has studied different ways of automatically creating descriptor sets for every class based on prompt templates, ranging from manually engineered templates over templates obtained from a large language model to templates built from random words and characters. In contrast, deriving zero-shot classifiers from the respective encoded class descriptors has remained nearly unchanged. That is, classify to the class that maximizes the cosine similarity between its averaged encoded class descriptors and the encoded image. However, weighting all class descriptors equally can be suboptimal when certain descriptors match visual clues on a given image better than others. In this work, we propose AutoCLIP, a method for auto-tuning zero-shot classifiers. AutoCLIP assigns to each prompt template per image weights, which are derived from statistics of class descriptor image similarities at inference time. AutoCLIP is fully unsupervised, has very low overhead, and can be easily implemented in few lines of code. We show that for a broad range of vision language models, datasets, and prompt templates, AutoCLIP outperforms baselines consistently and by up to 3% point accuracy. Effective long-context scaling of foundation models. We present a series of long-context language models, LLMs, that support effective context windows of up to 32,768 tokens. Our model series are built through continual pre-training from Llama 2 with longer training sequences, and on a dataset where long texts are upsampled. We perform extensive evaluation on language modeling, synthetic context probing tasks, and a wide range of research benchmarks. On research benchmarks, our models achieve consistent improvements on most regular tasks and significant improvements on long context tasks over Llama 2. Notably, with a cost-effective instruction tuning procedure that does not require human annotated long instruction data, the 70B variant can already surpass GPT 3.5, Turbo 16K's overall performance on a suite of long context tasks. Alongside these results, we provide an in-depth analysis on the individual components of our method. We delve into Llama's position encodings and discuss its limitation in modeling long dependencies. We also examine the impact of various design choices in the pre-training process, including the data mix and the training curriculum of sequence lengths. Our ablation experiments suggest that having abundant long texts in the pre-trained dataset is not the key to achieving strong performance, and we empirically verify that long context, continual pre-training is more efficient and similarly effective compared to pre-training from scratch with long sequences. Demystifying CLIP data. Contrastive language image pre-training, CLIP, is an approach that has advanced research and applications in computer vision, fueling modern recognition systems and generative models. We believe that the main ingredient to the success of CLIP is its data and not the model architecture or pre-training objective. However, CLIP only provides very limited information about its data and how it has been collected, leading to works that aim to reproduce CLIP's data by filtering with its model parameters. In this work, we intend to reveal CLIP's data curation approach, and in our pursuit of making it open to the community, introduce metadata-curated language image pre-training, MetaCLIP. MetaCLIP takes a raw data pool and metadata derived from CLIP's concepts and yields a balanced subset over the metadata distribution. Our experimental study rigorously isolates the model and training settings, concentrating solely on data. MetaCLIP applied to Common Crawl with 400M image text data pairs outperforms CLIP's data on multiple standard benchmarks. In zero-shot ImageNet classification, MetaCLIP achieves 70.8% accuracy, surpassing CLIP's 68.3% on VTB models. Scaling to 1B data, while maintaining the same training budget, attains 72.4%. Our observations hold across various model sizes, exemplified by ViTH achieving 80.5% without any bells and whistles. Curation code and training data distribution on metadata is made available at project's website. Deep geometrized cartoon line Inbetweening. We aim to address a significant but understudied problem in the anime industry, namely the in-betweening of cartoon line drawings. In-betweening involves generating intermediate frames between two black and white line drawings and is a time-consuming and expensive process that can benefit from automation. However, existing frame interpolation methods that rely on matching and warping whole raster images are unsuitable for line in-betweening and often produce blurring artifacts that damage the intricate line structures. To preserve the precision and detail of the line drawings, we propose a new approach, AnyMAL, which geometrizes raster line drawings into graphs of endpoints and reframes the in-betweening task as a graph fusion problem with vertex repositioning. Our method can effectively capture the sparsity and unique structure of line drawings while preserving the details during in-betweening. This is made possible via our novel modules, that is, vertex geometric embedding, a vertex correspondence transformer, an effective mechanism for vertex repositioning, and a visibility predictor. To train our method, we introduce MixamoLine 240, a new dataset of line drawings with ground truth vectorization and matching labels. Our experiments demonstrate that AnyMAL synthesizes high-quality, clean and complete intermediate line drawings, outperforming existing methods quantitatively and qualitatively, especially in cases with large motions. Data and code are available at the project's website. Diverse and aligned audio-to-video generation via text-to-video model adaptation. We consider the task of generating diverse and realistic videos guided by natural audio samples from a wide variety of semantic classes. For this task, the videos are required to be aligned both globally and temporally with the input audio. Globally, the input audio is semantically associated with the entire output video, and temporally, each segment of the input audio is associated with a corresponding segment of that video. We utilize an existing text-conditioned video generation model and a pre-trained audio encoder model. The proposed method is based on a lightweight adapter network, which learns to map the audio-based representation to the input representation expected by the text-to-video generation model. As such, it also enables video generation conditioned on text, audio, and for the first time, as far as we can ascertain, on both text and audio. We validate our method extensively on 3 datasets, demonstrating significant semantic diversity of audio-video samples, and further propose a novel evaluation metric, AV-align, to assess the alignment of generated videos with input audio samples. AV-align is based on the detection and comparison of energy peaks in both modalities. In comparison to recent state-of-the-art approaches, our method generates videos that are better aligned with the input sound, both with respect to content and temporal axis. We also show that videos produced by our method present higher visual quality and are more diverse. CCEdit, creative and controllable video editing via diffusion models. In this work we present CCEdit, a versatile framework designed to address the challenges of creative and controllable video editing. CCEdit accommodates a wide spectrum of user editing requirements and enables enhanced creative control through an innovative approach that decouples video structure and appearance. We leverage the foundational ControlNet architecture to preserve structural integrity while seamlessly integrating adaptable temporal modules compatible with state-of-the-art personalization techniques for text-to-image generation, such as DreamBooth and LoRa. Furthermore, we introduce reference-conditioned video editing, empowering users to exercise precise creative control over video editing through the more manageable process of editing keyframes. Our extensive experimental evaluations confirm the exceptional functionality and editing capabilities of the proposed CCEdit framework. Demo video is available at the project's website. RealFill, reference-driven generation for authentic image completion. Recent advances in generative imagery have brought forth outpainting and inpainting models that can produce high-quality, plausible image content in unknown regions. But the content these models hallucinate is necessarily inauthentic, since the models lack sufficient context about the true scene. In this work, we propose RealFill, a novel generative approach for image completion that fills in missing regions of an image with the content that should have been there. RealFill is a generative inpainting model that is personalized using only a few reference images of a scene. These reference images do not have to be aligned with the target image and can be taken with drastically varying viewpoints, lighting conditions, camera apertures, or image styles. Once personalized, RealFill is able to complete a target image with visually compelling contents that are faithful to the original scene. We evaluate RealFill on a new image completion benchmark that covers a set of diverse and challenging scenarios, and find that it outperforms existing approaches by a large margin. See more results on our project's website. ConceptGraphs, open vocabulary 3D scene graphs for perception and planning. For robots to perform a wide variety of tasks, they require a 3-dimensional representation of the world that is semantically rich, yet compact and efficient for task-driven perception and planning. Recent approaches have attempted to leverage features from large vision language models to encode semantics in 3-dimensional representations. However, these approaches tend to produce maps with per-point feature vectors, which do not scale well in larger environments, nor do they contain semantic spatial relationships between entities in the environment, which are useful for downstream planning. In this work, we propose ConceptGraphs, an open vocabulary graph-structured representation for three-dimensional scenes. ConceptGraphs is built by leveraging two-dimensional foundation models and fusing their output to three-dimensional by multi-view association. The resulting representations generalize to novel semantic classes without the need to collect large three-dimensional datasets or fine-tune models. We demonstrate the utility of this representation through a number of downstream planning tasks that are specified through abstract language prompts and require complex reasoning over spatial and semantic concepts. Project page, project's website, explainer video, project's website. Language models in molecular discovery. The success of language models, especially transformer-based architectures, has trickled into other domains, giving rise to scientific language models that operate on small molecules, proteins, or polymers. In chemistry, language models contribute to accelerating the molecule discovery cycle, as evidenced by promising recent findings in early-stage drug discovery. Here, we review the role of language models in molecular discovery, underlining their strength in de novo drug design, property prediction, and reaction chemistry. We highlight valuable open-source software assets, thus lowering the entry barrier to the field of scientific language modeling. Last, we sketch a vision for future molecular design that combines a chatbot interface with access to computational chemistry tools. Our contribution serves as a valuable resource for researchers, chemists, and AI enthusiasts interested in understanding how language models can and will be used to accelerate chemical discovery. GPT-Fathom, benchmarking large language models to decipher the evolutionary path towards GPT-4 and beyond. With the rapid advancement of large language models, LLMs, there is a pressing need for a comprehensive evaluation suite to assess their capabilities and limitations. Existing LLM leaderboards often reference scores reported in other papers without consistent settings and prompts, which may inadvertently encourage cherry-picking favored settings and prompts for better results. In this work, we introduce GPT-Fathom, an open-source and reproducible LLM evaluation suite built on top of OpenAI evals. We systematically evaluate 10+ leading LLMs as well as OpenAI's legacy models on 20+ curated benchmarks across 7 capability categories, all under aligned settings. Our retrospective study on OpenAI's earlier models offers valuable insights into the evolutionary path from GPT-3 to GPT-4. Currently, the community is eager to know how GPT-3 progressively improves to GPT-4, including technical details like whether adding code data improves LLM's reasoning capability, which aspects of LLM capability can be improved by SFT and RLHF, how much is the alignment tax, etc. Our analysis sheds light on many of these questions, aiming to improve the transparency of advanced LLMs.